In sections 10.1, 10.2, and 10.3, we're going to talk about graphing sine and cosine graphs. So first we have a demonstration of how these graphs are generated. So notice on our axes we are working in radians on the x-axis, so we go from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi. And our y-axis doesn't go very high. And notice over here we have our unit circle. So we know sine of 0 is 0. So if I'm going to start drawing the sine graph, it's got the point 0, 0. Then, as I move the cursor up here, and I'm going to do it in just a second, sine on the unit circle is the y values. So as I come along here and I move for these angles, notice the y values are getting bigger. Y is getting bigger and bigger and bigger on the circle until we get to right there at pi over 2. At pi over 2, sine is 1. So that's the first part of the graph. From 0 to pi over 2, it looks like that. Now, when I move the cursor along here, notice that the y values are getting smaller. The y value here is 1, for example. The y value here is about a half. So as I come along, as I move, as I'm picking angles in quadrant 2 now, my y values are shrinking, and you can see that on the sine graph over there on the right, until I get to here, where my angle is pi. At pi, sine of pi is 0. As I continue to move down, I move into the third quadrant. In the third quadrant, my y values are negative, so my sine graph is going to come down here below the axis. And you can see that the y values are negative. When I get to 3 pi over 2, I hit the lowest value, where sine is negative 1. And then I continue here in the fourth quadrant, between 3 pi over 2 and 2 pi. My y values are still negative, but now they're getting bigger. This is negative 1 down here. This will be about negative a half here, and eventually we'll get up to 0. So we can see that. We trace along, and there we are. So this is called one period of the sine graph. It starts at 0, goes up, comes back down, and ends at 2 pi. That's one period. Now, if I kept going, notice I would just keep wrapping around the circle, so my y values would come back up, then they would go back down, and so on and so forth. All right, so a couple important words we're going to use here. First off, we're going to say the period is 2 pi. That's the length of one cycle. And then we're going to say the amplitude is 1, because that's the highest y value that we get. All right, so notice important things about sine graph. It starts at 0, 0. It ends on the axis. It hits the axis in the middle. And it's high here and low there. All right, now let's switch to the cosine graph. The cosine graph on our unit circle, cosine is the x values. So at 0, the x value here is 1, so cosine is going to start at 0, 1. And then my x numbers, as I move along here, my x values are getting smaller until I get to pi over 2. At pi over 2, the x value is 0. So notice the cosine graph is different from the sine graph. The cosine graph starts up high, and then it starts to come down. Once I get to pi over 2, and I move over here into quadrant 2, between pi over 2 and pi, the x values are negative. So my cosine graph is going to go down below until I get to pi, where it hits its low point at negative 1. Continuing here in quadrant 3, cosine is still negative in quadrant 3, but the x values are getting bigger. Even though they're negative, they're getting bigger and bigger until I get to 3 pi over 2, where I hit the axis again. And then over here in quadrant 4, x is positive. Cosine is positive in quadrant 4, so it goes back up above the axis. Oops, I went a little too fast there. It didn't trace very well. Let me fill in those dots. There we go. That's better. All right, so the cosine graph starts high, ends high, is low in the middle, and hits the intercept, hits the axis in 2 spots. Okay, so now I'm going to switch to a different graphing thing. So what you can see here is I have the graph of sine x. Same graph we saw a minute ago. It starts at 0, it goes up, down, and back up, and completes one cycle in a length of 2 pi. And then it keeps going. It goes in this direction, and it goes in that direction, and it cycles over and over and over again, infinitely long. Our amplitude is 1, because that's our maximum height, and our period is 2 pi. Now, what happens if I put a number in front like 3? All right, so you can see what it did. What it did is it kind of grabbed the graph right here and stretched it up, and also grabbed the graph here and stretched it down. Notice it still starts at 0, 0. It still ends at 2 pi 0. It's still 0 in the middle, but it changed what we call the amplitude. We would now say the amplitude of the blue graph is 3, because that's the highest point. And its lowest point is -3. So this number out front changed the amplitude. Didn't really change any of the x values. They're all the same. Really changed the y values. What if I make this a small number like 1/2? Well, again, you can see what it did. It changed the amplitude. Instead of the amplitude being 1, the amplitude is now 1/2, because that's our highest point. So having a fraction here like a 1/2 shrinks the graph, changes the amplitude. Period is still the same. It goes through one complete cycle in a length of 2 pi, but the amplitude is different. Instead of the amplitude being 1, the amplitude is 1/2. How about a negative number? All right, so a negative number did 2 things. First off, it changed the amplitude. Notice the amplitude is now 2. Amplitude's always given as a positive number. Amplitude is always the high point. So the amplitude is now 2. But the other thing it did is it flipped the graph over. The red graph goes up at the beginning and then down. This one goes down at the beginning and then up. So a negative in front does 2 things. It changes the amplitude, changed it to 2, and it flips the graph upside down. Okay, here's the good news. Exactly the same thing happens if I switch this to cosine. All right, so our cosine graph that we saw a few minutes ago starts high, starts at 0, 1, and it goes through one complete cycle in a length of 2 pi. Notice what happens if I put a -2 here. A -2 changed the amplitude. The high point is now 2, and it flipped it upside down. So instead of starting at 0, 1, it starts at 0, -2. Then it goes up to our high point and down to our low point. If I were to change this back to a positive number, like 3, you can see it does exactly the same thing as it did for sine. It grabs it and stretches it up, and grabs it here and stretches it down. Changes our amplitude. So our high point is now 3, our low point is -3. All right, I'm going to go back to sine. And now I'm going to look at what happens if I put a number inside the parentheses here. All right, so now we've got a pretty big change here in our graph. Notice the amplitude is still the same. The highest point is still 1. But look what it did. On the red graph, one complete cycle is a length of 2 pi. Now that I have the 2x here, it changed what we call the period. The period is now only a length of pi. It cut it in half. So it goes from the origin up to its high point, down to its low point, back to the axis in a length of pi. So putting a number here like 2 shortens the period. And I'm betting you're already figuring this out, that putting a fraction there like 1/2 lengthens the period. So notice now it starts at 0, 0. It goes up, back to the axis, down, finishes its cycle. You can't quite see that because it goes off the graph here at 4 pi. I know you can't see that because my camera view isn't wide enough, but you'll just have to believe me. It ends at 4 pi. So putting a number here changes the period. It changes these x values that we use. Instead of 0, 0, that one's the same, but instead of the high point being at pi over 2, the high point is now pi. All right, same thing happens with cosine. Let's say I put a cosine of 3x there. All right, so this one's a little harder to tell, but you can definitely see the period is shorter. The red graph, the period takes all the way to 2 pi. The blue graph, you can see the period is much shorter, and the period is 2 pi over 3. Okay, so here's something hopefully you're recognizing. When I had my cosine graph, when I had my sine graph, and I had sine of 2x, the period became pi, became half as much. If I put a 3 here, my period is now 2 pi over 3. So my period always starts at 2 pi, and then it gets divided by whatever this number is. Okay, same thing works as if I put a fraction here. Let's say I put, I don't know, how about 2/3. So again, you can see what it does. It stretches it out. Instead of my period going to 2 pi, one complete cycle takes longer, takes all the way to 3 pi now. Stretches it out. Okay, so now we're going to go to graph by hand. And what we're going to want to learn by hand is how to compute the amplitude, how to compute the period. Those are quite easy, we'll see. And then when we draw the graph, we want to mark the 5 key points. What I mean by that is we'll want to know, where does it start? Where does it end? Where are the low points? And where are the intercepts? And it'll be the same process whether we're doing sine or cosine. All right, so this is the introduction to this section, using technology to see what's happening. And now in part 2, we'll go to the paper and we'll do some graphs by hand.